Hello everyone. In the last class, we have discussed about seismic evaluation of masonry buildings. In today's class, we will take our discussion forward towards seismic strengthening of these existing masonry buildings. We will first look into how do we achieve seismic restoration or repair of these masonry buildings, then we will move to strengthening and further to retrofitting. Earlier, we have looked into the difference between seismic repair, seismic strengthening and seismic retrofit. So, with this preamble, let us start with seismic repair of existing masonry building. So, before conducting any structural repair or restoration of existing masonry building, we need to conduct proper assessment. So, that assessment shall be detailed in nature and the intent shall be to determine the present structural condition of a building to decide whether the structure or the building is amenable for repair, whether the continued occupation is permitted or not, whether the structure as a whole or a part requires demolition. So, all of these things are very important. If a structure is found to be amenable for repair, then only we can do the repair. If a structure is found to be unsafe for occupation, then we cannot permit the continued occupation of the building. If a part of a structure or the whole structure requires demolition, that is the reconstruction cost is comparable to the retrofitting or restoration cost, then in that case we may have to demolish the building as such. So, if the building is considered amenable for structural repair, we will conduct a detailed damage assessment of individual structural components now. Earlier we have done the detailed damage assessment of the entire building, but once the building is considered to be suitable for a structural repair, we will do the detailed damage assessment of individual structural components, in which we will do the mapping of crack pattern, we will identify the distress location, we will also look at the crushed concrete and reinforcement bending or yielding. So, all these distress signs we will record. We will also perform some non-destructive testing to determine the residual strength of the member. We also have some non-destructive testing related to masonry walls as well. For that, you need to look into relevant literature. Now, after doing this, we shall work out the details of the temporary supporting arrangement, that is props. These props will help us to prevent further distress in the already distressed member under the gravity loads. So, that is how the props are important, so that there is no further distress in the distressed member while we are conducting our structural repair or restoration. So, after we are done with all these assessment, now we can get to the structural repair or restoration. There are multiple strategies for that. Let us look into some common strategies. These are obtained from clause 4.2 of IS 13935 2009. I suggest that you keep a code copy with you, so that you can have a look while you go through these video lectures. So, the first strategy is to remove the portions of the cracked masonry walls. You take away those masonry units and mortar where your wall has got significant damage, and then you can put new masonry units and mortar and rebuild them. This time you shall be using a richer mortar, preferring non-shrinking mortar. Many times what you will find that there is a crack in the wall, and then for those cracks you may add a reinforcing mesh on both sides of the cracked wall, holding it to the wall through spikes or bolts. So, you shall be using a wire mesh, reinforcing mesh on both sides of the wall, and then you shall connect those mesh with the wall through spikes or bolts, and then you shall cover it with micro concrete. What is micro concrete? Micro concrete is a concrete where you use aggregates with maximum size 6 mm or less. You do not use very coarser particles, so that you can use it on both sides, so that the reinforcing mesh stays there with the wall. Further, the third strategy is to inject cement or polymer cement mixture or any epoxy material which is strong in tension into the wall cracks. So, this is also very commonly done. Now, if your RC element in a masonry building such as slab or some horizontal band, they have a crack, then you can also go for epoxy grouting, and after epoxy grouting you can apply shotcreting or jacketing on the surface. In the jacketing you can also have use of reinforcing mesh. Okay. Having understood these repair or restoration strategies, now let us look into some of these strategies, particularly from the application perspective. So, let us first look about a structural repair of minor and medium cracks, that is the crack width is ranging between 0.5 and 5 millimeters. So, minor and medium cracks, in this case mostly we have the solution as pressure injection of non-shrink cement polymer grout, and is appropriate for all the structural elements even in reinforced concrete buildings apart from masonry buildings. So, in this case what do we do? First of all, we clean the external surface of the to get rid of non-structural materials which might be sticking over there. Then we shall place plastic or aluminum injection ports. In this figure you can see we have these ports which are placed along the surface of the crack on both sides of the member. So, we have placed it along the surface of the crack. Then we are securing these injection ports in place using polyester putty or 1:3 cement mortar. The spacing between these ports is very important. So, the center to center spacing should be approximately equal to the wall thickness. This is based on practice, and then we connect the injection equipment to one of these ports. Now, which ports we shall be connecting first? In case of a horizontal crack, we can start at either end, but if you have a vertical crack or an inclined crack, then we will start with the lower end, and then we will clear the cracks using compressed air or water. So, what we do is that we pump in compressed air or water so that the cracks get cleaned. This is very important to be done before injecting any grout. Why? Because if you do not clean these cracks, then in that case the grout may get blocked and the cracks may not be filled adequately. How will they get blocked? Because of the pulverized concrete or dust which is inside the crack. Okay, after clearing these cracks, we will inject grout in one port at a time. We will start with any end in case of horizontal cracks, while in vertical cracks we will start with the lower end. And when shall we stop injecting the grout in the port? When we see that the grout is overflowing from the corresponding port on the other side of the wall or the next higher port on the same side of the wall. Then in that case we will stop injecting the grout and we will close the injection port and we will move our injection equipment to the next port. So, that is how we will complete the pressure injection of non-shrink cement polymer grout and the structural repair of minor to medium cracks. Now, if your cracks are very fine, then in that case you will require a higher grout pressure and a closely spaced ports. If your cracks are wide, then you shall require lower grout pressure and a sparsely spaced ports. Okay. So, having understood this, now let us look into a structural repair of major cracks, that is cracks which are wider than 5 millimeters or it may have some crushed concrete. So, in this case the first step shall be to remove loose material and replace it with special materials. What are the special materials? It can be non-shrink grout, it can be shotcrete, it can be epoxy resin, epoxy mortar or quick setting cement mortar. The details of all these materials are provided in some clauses of IS 13935 2009. You can have a look into those clauses for greater depth of understanding. Then we shall also provide additional shear and flexural reinforcement if required, and we will also cover them with mortar to further strengthen and protect the additionally provided reinforcement. Sometimes in case of very severe damage, we may need to replace the member. When the replacement cost becomes comparable to the repair cost, then we can go for replacement of the member as well. We can also provide the steel mesh on the surface of the wall on either side and bolt it to the wall through nail or bolt, and then we will cover it with plaster or micro concrete. We can also do shotcrete as well. So here it is shown, we have placed a steel mesh on wall surface on either side. We can see only on the one side, the other side may not be visible in this. We have used a special grout after removing the loose material in these cracks, and then we have plastered the surface to contain the steel mesh on the wall surface as well. Now, if your concrete member is severely damaged, in case of a masonry building, there is a RC member which is severely damaged, then for such members we will replace the old portion of the steel with new steel using butt or lap welding. Then we will provide additional stirrups or ties in the damaged portion. This will ensure that the longitudinal bars are effectively confined and enclosed to prevent buckling in future. We will anchor the additional steel into existing concrete. For this, we shall drill a hole which is larger than the bar diameter. We will fill the hole with epoxy expanding cement or other high strength grouting material, and then we will push the bar into place and hold it until the grout has set. Then finally we will apply concrete to obtain a jacketed surface. So in this case we have actually ended up providing additional longitudinal steel into the existing concrete. Okay. Now when we have understood structural repair or restoration, let us look into non-structural repair or restoration. We can have multiple of them in a masonry building. For example, we may need to patch up defects such as cracks and fall of plaster. Cracks and fall of plaster is a non-structural damage. We can repair that as well. Then repairing of doors, windows and replacement of glass panes, checking and repairing electrical conduits and wiring, checking and repairing gas pipes, water pipes and plumbing services, rebuilding non-structural walls, smoke chimneys, parapet walls, then replastering of walls as required, rearranging disturbed roofing tiles, relaying cracked flooring at ground level, then redecoration which may involve whitewashing and painting. So a large number of appropriate non-structural repair or restoration strategies can be done. Please make sure that to understand that it is also very important to protect these non-structural components, because it adds to the durability of the structural components. However, the structural repair or restoration must be conducted before implementing any non-structural repair or restoration. Why? Because suppose your slab is having a damage and you only rearrange the disturbed roofing tiles. From outside it will look perfectly fine, which will give you a false impression of seismic safety, but it is having a real problem. So that is why you must implement a structural repair or restoration prior to non-structural repair or restoration. Now we have looked into repair and restoration. We will look into seismic strengthening. As we have understood earlier that the purpose or objective to seismic strengthen any building is to upgrade the seismic resistance of that damaged building while repairing, so that it becomes safer under future earthquake occurrences. Now there are a lot of techniques to strengthen a masonry building. We can increase the lateral strength in one or both the actions. For this, we will increase the number and dimensions of column and wall. We will imbibe unity in the building to ensure transmission of inertial forces to capable elements during an earthquake. What does it mean? So, for example, there are some damaged members in any given building, but there are some members which are capable. So, what we will do is that we will provide proper connection between these members so that the load transmission or the inertial forces during an earthquake is transmitted to those capable members during the earthquake. So, this essentially means providing good connection or proper connection between various resisting elements such as floor to wall connection, roof to wall connection, wall to wall connection, wall to foundation connections. All of these connections are very important. We can also try to eliminate sources of weakness or stress concentration. What are these? Asymmetric plan distribution of resisting members, abrupt stiffness change over consecutive floors, concentrated large masses, large openings in walls without provision of bands. So, we will try to eliminate these sources of weakness as they add to stress concentration around them, and we want these stress concentration not to be happening in our building. We will also avoid possibility of brittle mode of failure. How do we do that? By providing proper reinforcement and connection of resisting members. There are some more techniques to achieve seismic strengthening, such as grouting of cracked or uncracked walls. For this, we first drill holes in the wall. We will inject water to clean the holes and improve cohesion between grout and wall elements. If you do not inject water, the holes may have dust and all, which will block the grout movement. Also, the dry concrete or the dry masonry will try to absorb water from the grout. So, the grout will not be able to achieve its properties. Therefore, it is important that all these holes are not just cleaned, but they are also wet before pushing grout inside. So, what shall we inject? We shall inject cement water mixture, which is 1:1, means very rich kind of mixture. There is no sand in this, or polymer cement mortar at low pressure, which is at 0.1 to 0.25 megapascal. Again, we will start with the lower holes and go up in case of a vertical crack. This we have seen in case of seismic repair as well earlier in today's class itself. We can also go for a strengthening with wire mesh in case of severe damage. In this case, we will reinforce wall with galvanized steel wire fabric, which is commonly available as 50 mm by 50 mm on either side of the wall. We will apply 20 to 40 mm thick cement mortar or micro concrete layer on either side of the wall, so that this wire fabric is attached to the wall securely. Then we will connect the reinforcing layers on either side by galvanized steel rods, which are spaced at 300 to 400 millimeters. What does this mean? So, we will drill a hole through the wall and we will connect the reinforcing layers on the both sides, that is the steel wire fabric. We will connect using the galvanized steel rods, and these rods shall be placed at a spacing of 300 to 400 millimeters. Okay. Then in case of stone masonry walls, you have perpendicular walls like this, and if we want to connect them for good behavior during an earthquake, you need to have good connection between different components, as we have seen in the last slide. Then in that case, we will drill inclined hole in the stone walls and we will insert steel rods and inject cement grout. Okay. Then if you have masonry arches such as those shown over here, then we shall install tie rods at a springing level or slightly above the springing level also you can provide. Then second approach is that you can also provide a lintel or a band consisting of a steel channel or I section just above the arch. What will this do? This will distribute the load to this pier and this pier effectively, and the arch will not have to do that. So, the arch will no longer be under compression, and therefore, it takes the load from the arch and relieves the arch. Okay. Sometimes in older buildings you will find that they have jack arch roof. What is jack arch roof? You will have multiple arches in the roof. So, from within the structure you can see on the roof there will be jack arch roof. So, in this case we shall install flat iron bars or rods to connect the bottom flanges of I-beam. As you can see, there is a I-beam going through at these points in the jack arch roof. So, we will connect a rod and we will connect it to these I sections either by bolting or welding. There are some more seismic strengthening techniques which are related to provision of seismic belts around the opening. Now, the difference between seismic band and belt is that seismic band is provided in the same plane as the wall around the opening, but if you do not have a seismic bands provided in the wall, then what will you do? You will provide seismic belt. It will be in the similar plane, but it will be protruding out of the wall. So, there is a wall, you do not have the seismic bands around this opening. So, you will provide seismic belt around the opening, but in the outside of the wall. Okay. We also want to achieve integral box action in case of masonry building. So, that is why we have been reiterating on providing horizontal and vertical bands, because that gives us good box action, and if our masonry buildings have a integral box action, the behavior or the seismic response is really good. So, there are multiple ways to achieve this integral box action apart from the provision of bands and belts. We can also provide pre-stressing of walls using steel rods. Then horizontal and vertical seismic bands or belts, then vertical reinforcement at wall, corners and junctions, as you can see. Okay. More details are available in section 11 of IS 13935. I suggest that you have a look at the IS code as well. Now, let us look further into seismic retrofitting, where our objective or purpose is little higher, that is, we want to upgrade the seismic resistance of the damaged building to the level of the present day codes IS 4326 and IS 13828 in this case, using appropriate seismic strengthening techniques. And in this case, we shall consider the importance factor 1 or 1.5 based on IS 1893 2016. But if you have any heritage building, most of the heritage buildings are masonry buildings, and therefore, if you are going for conservation of or retrofitting of a heritage building, then in that case the importance factor shall be equal to 2. In this case, what shall be the seismic retrofitting techniques? First of all, it has to be very similar to seismic strengthening techniques, but apart from this, there shall be further attempt or approach for compliance to latest codes such as IS 4326. Now, let us look into some more examples. Now, if your mortar is not suitable as per IS 4326 in the building, the mortar which has been used in the construction long back, let us say 30-year-old building, and you find today that the mortar which they have used is, let us say, a poor quality mortar which is not admissible as per IS 4326 for the given seismic zone of the site. But the change of mortar is not feasible, right? Then in that case, what we will do is that we will fill the hollow portions with the grout. Then this diagram is obtained from IS 13935 and it is also available in IS 4326, where it gives you various specifications related to what shall be the minimum distance between the cross wall and the opening, what shall be the minimum distance between two openings, what shall be the maximum height of the opening, and so on. So, all those things we need to comply, because in retrofitting we want to comply to the latest code IS 4326. How do you ensure that compliance? Sometimes you may have to close some opening, sometimes you may have to narrow down some openings to comply with this geometrical detailing. You may have to reinforce the openings by installing seismic belts, okay, and sometimes if there is very little number of cross walls, then you may have to provide pilaster or buttress in the midspan. You may have to provide RC headers in the holes made by removing stones. Okay. Apart from these seismic retrofitting techniques, let us summarize how do we decide what kind of retrofitting actions we need to take for a given building. It depends on the damageability grade. We have discussed about damageability grade in the last class, where we have discussed that there are 5 different grades which are available in IS 13935, G1, G2, G3, G4 and G5, where G1 implies the least amount of damage and G5 represents the highest form of damage. If the damage is of damageability grade G1, that is negligible or no damage, then in that case you do not have to worry, you do not have to do anything. But if the damageability grade is G2, that is moderate damage, then you may have to retrofit non-structural elements. You may not think about retrofitting structural elements. Now, why I am saying that even if the damage is moderate, you do not have to retrofit structural elements? Because by now you must be clear in your mind related to what is retrofit. Retrofit is the process where you want to upgrade the seismic resistance to the current day code. So, you may have to perform seismic strengthening, you may have to perform seismic repair or restoration, but that does not mean that you have to reach to the present day code level. So, in that case you do not have to retrofit the structural elements. In case of damage grade G3, that is high or heavy damage, in that case we shall be retrofitting non-structural as well as structural elements. We will also evaluate global and local deficiencies and design some suitable retrofitting. For G4, that is very heavy damage, again the similar pattern is seen, but when the damageability grade is of the highest grade, that is G5, means nearing collapse, then in that case we will retrofit non-structural as well as structural element. We will also evaluate global and local deficiency and design suitable retrofitting, but at the same time we shall also explore replacement of the existing building with new earthquake resistant building. Why? Because in this case the cost of retrofitting will be very high and it may be comparable to the reconstruction cost of a similar building, but with good earthquake resistance. So, in that case we may explore replacing this very existing building with new earthquake resistant building. So, summarizing, in this class we have looked about different forms of interventions in masonry buildings, that is structural repair or restoration, seismic strengthening and seismic retrofitting. We have looked into how damageability grade, which again depends on seismic hazard of the region and the building type, affects your seismic retrofit actions. With this understanding, in the next class we will look into some specialized ways to improve seismic resistance of buildings or to achieve seismic protection of buildings. Thank you.